Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Lebenz, joined by my co-host, Eric Torenberg.
This episode is brought to you by WorkOS. If you're building a B2B SaaS application, at some point your customers will start asking for enterprise features like SAML authentication, SCIM provisioning, role-based access control, and audit trails. That's where WorkOS comes in, with easy-to-use and flexible APIs that help you ship enterprise features on day one without slowing down your core product development. Today, some of the hottest startups in the world are already powered by WorkOS, including ones you probably know like Perplexity, Vercel, Jasper, and Webflow. WorkOS also provides a generous free tier of up to 1 million monthly active users for user management, making it the perfect authentication and authorization solution for growing companies. It comes standard with rich features like bot protection, MFA, roles and permissions, and more. If you're currently looking to build SSO for your first enterprise customer, you should consider using WorkOS. Integrate in minutes and start shipping enterprise plans today.
Hello, and welcome back to the Cognitive Revolution. Today, I am thrilled to share my conversation with Judd Rosenblatt and Mike Vaiana, CEO and R&D Director on the alignment team at AE Studio. This episode is both technically deep and highly inspirational. It's really a perfect example of why I love making this show. AE Studio's story is genuinely amazing. They started with a plan that sounds, frankly, too complicated to work. Bootstrap a software consulting business and then use the profits to fund work on effective altruism causes. And yet, they've pulled it off, demonstrating unusual levels of organizational agility and responsiveness to the fast-changing AI environment along the way. After first choosing to focus on brain-computer interface technology and building real capability in that notoriously challenging domain, they, like many others in the field, recently concluded that the timeline to AGI could be just a few years, and that if so, this would not be enough time for their brain-computer interface work to pay off in the way that they'd hoped. With that in mind, they took a step back to survey the field. Quite literally, they conducted a survey of AI alignment researchers, which showed that most researchers do not believe we are collectively on track to solve alignment issues before powerful AI systems come online. And based on that finding, they ultimately pivoted into new research agendas with plausibly shorter timelines to pay off. Now, just months later, they've produced 2 notable AI alignment results, using biologically inspired approaches to design more cooperative and less deceptive AI systems. Importantly, they've managed to implement these strategies in relatively straightforward, understandable ways that don't require breakthroughs in interpretability or any other area of AI safety in order to work. We spend the majority of today's conversation going deep into these latest publications, both of which are among my favorites of 2024. First, what happens when you train an AI model not just to do a certain task, but also to model its own internal states? This is an important part of human cognition, and it turns out not only that models can do this, but that they accomplish it in part by simplifying their internal states, thus becoming easier for others to understand as well. Second, what happens if we attempt to minimize the difference in the way that AI systems represent self versus other? We know that humans cooperate well in part because we use the same cognitive processes to model others as we use to model ourselves. And again, with a clever but relatively simple setup, it turns out that self-other distinction minimization can train an already deceptive AI agent to be honest once again. About this result, Eliezer Yudkowsky said, "Not obviously stupid on a very quick skim. I rarely give any review this positive. Congrats." Personally, after going deep on the topic, I'm a bit more enthusiastic than that. I really love this work, and it gives me real hope for more eureka moments that could move the needle on AI safety. Of course, AE Studio is not resting on their laurels. They are still actively seeking out, evaluating, and investing in neglected but high potential impact approaches to AI safety, even if at first glance they seem unlikely to succeed. As always, if you're finding value in the show, we'd appreciate it if you take a moment to share it with friends. I want to specifically encourage listeners to share this episode with a friend who might have their own neglected approach to AI safety. Too often, all these individuals hear is that their ideas are crazy and will never work. And while that might be true in many cases, we do need people to take personal career risks in the public interest. And Judd and Mike's recent work demonstrates that it's often the unconventional ideas that yield the most important results. We welcome your feedback and suggestions via our website, cognitiverevolution.ai, and you're always welcome to DM me on your favorite social network. Now, I hope you enjoy this outstanding conversation about pursuing and succeeding with neglected approaches to AI safety with Judd Rosenblatt and Mike Vaiana of AE Studio. Judd Rosenblatt and Mike Vaiana, CEO and R&D Director on the alignment team at AE Studio. Welcome to the Cognitive Revolution.
Thanks for having us.
You guys have built a remarkable company with a fascinating backstory and some really interesting recent work. So we've got a lot to cover. As you know, regular listeners know, I very seldom ask the backstory question. I think yours is quite different. So I'd love to give you the chance to tell the backstory of how you started AE Studio, what the mission is, and how you've developed the company to what it is today.
Thanks again for having us. The backstory of AE is basically back in 2016, I realized that I had the luxury of living off my wife's salary and never having to work again. That freed me up to think more deeply about the long-term future of technology and humanity. One thing I thought a lot about is that I sometimes like to think long, complicated thoughts that take a while to convert into words. By the time I convert them into words, I might say something entirely different from what I imagined in my head. Humans aren't very good at communicating to their future selves, let alone other people, compared to what they might be with better tools of thought. I considered that there might be a low probability that within my lifetime, humanity's primary mode of interaction with computers might come to be via brain-to-computer interfaces. If that does come about, it would be very good to try to make it come about in a way that's more agency increasing for the end user, instead of manipulating people to do things they don't want to do and interrupting them mid-thought with ads, and having Mark Zuckerberg own the extensions of their thoughts. And two, it might be a way to make humans sufficiently smart and wise enough to be better able to solve some of humanity's greatest challenges, including solving AI alignment. And I continue to think there is a possibility we need substantial human augmentation to solve the alignment problem. I decided to create a profitable bootstrapped software and AI product development consulting business, building products for clients without taking any money from investors. We like to build products that increase what we talk about as human agency, the idea being that it's better business sense in the long run to increase your end user's agency. It makes users like you more, want to use you more, spend more money, and refer their friends to do the same. Taking that same philosophy with the work we do with clients and making great value for them and having them want more work and refer their friends led us to grow the consulting business to over 160 people. We took the profits of the consulting business to invest in building our own agency increasing startups. So we built and sold the first one of those and plan to incubate quite a lot more in the future as well. We take the capital that we produce from these businesses and invest them originally in trying to build maximally agency increasing BCI software without profit motive to help people with neurological injury and disease increase their agency, but also in the future make the nature of human existence substantially better and make us smart enough to solve the alignment problem. The consulting business grew. We sold the first startup. We made a name for ourselves in the BCI world and worked with top BCI hardware companies. Super excited about the work we did there, pushing people to build things in more agency increasing ways than they otherwise would have done. A few years ago, after I had kids, I was paying attention to what was happening with AI because we build stuff with AI ourselves all day, noticing that timelines might be shrinking faster than I would have hoped. We have this unique structure where we are, unlike all the other for-profit businesses that have anything to do with AI alignment, we are not incentivized to create AGI ourselves. We don't have any investors. We don't have to have returns to them. And we instead can do the right thing long-term for humanity and consciousness in general. We also are entrepreneurial and good at getting stuff done and getting to the root of the problem. And we have to be because we're paid to do that for clients. We have this AE guarantee, which is that we will treat your client project as though it is our own startup, as though we are founders of your own startup. Everyone is constantly priming themselves and reminding themselves of that every day, which means that the top idea on their mind is often while they're taking a shower or walking the dog, thinking about how, if I were a founder of the startup, how would I make it super successful? And it's great that isn't just the case for client projects, but also for the work that we do with BCI, which allowed us to have a real impact there. Just trying to solve the alignment problem, maybe we should put the profits of the company into alignment. And we didn't know how to do that at first. We spent a lot of time thinking about and researching how to have the biggest positive impact there. and eventually realized that with the effective altruism ITN framework, the highest impact thing to do is actually things which are individually unlikely to work, but very high impact if they do work, neglected approaches. The BCI thing we were going to start with was a neglected approach, and it worked better, faster than we would have guessed, but still the timelines would be much longer for sure. We concluded that we should work on neglected approaches ourselves. One of the neglected approaches we realized is potentially impactful is encouraging others to work on neglected approaches too. It's interesting that the highest expected value thing to do is work on these neglected approaches, but that's mostly not what people are doing. Historically, we're excited to see people work on more and more neglected approaches, to do them ourselves internally, which we're working on, and excited to talk about the specific ones that we've worked on and shared publicly so far. Also excited to encourage the alignment community to work on more and more neglected approaches and realize that individuals can start a startup, which everyone else thinks is going to fail. You can also work on a neglected approach to alignment that no one else believes in. It might just work.
I love it. There's an unbelievable amount there that I want to dig into. I guess for starters, at a high level, this plan sounds kind of crazy. If I heard this at a startup pitch competition, or if somebody sent me a 2-pager with the plan that you have executed already, I would say there's way too many steps in this plan. It's going to be really hard to bootstrap a consulting business and be profitable enough to do these other things. And you're going to have a tug of clients pulling you in one direction. So what would you say are the keys to the success that you've had in building a business, having these lofty priorities, executing on the day-to-day, but actually keeping those in mind and staying agile enough to actually, we're not talking about incremental changes to your strategy here, but pretty significant fundamental changes. Maybe you have some tricks or some special attributes that put the odds more in your favor, but I would love to know what they are.
I do think that it's an unconventional path, and because it is so unconventional, the assumption is that it's not going to work. There are all sorts of things that are unlikely to work, and also all sorts of things that are likely to work. But the things that haven't been done before, people are more likely to assume are not going to work. I remember when I was first starting the company and outlined the plan to people, everyone was like, that's crazy. Of course, that's not going to work. I think a lot of the reason why it has been that it's a de-risked conservative approach in fairly ambitious things. And I think we're doing it for the right reasons. It was impactful to realize that I wasn't motivated by money and I could live off my wife's salary for the rest of my life, and then realize that I could think very long term about the future of technology and humanity. And if you do the right thing every step of the way, then it winds up like yielding better results for you as best you can over time. There's this really interesting Paul Graham essay called Mean People Fail, which puts forth the idea that we are moving from a world in which you've got more resources by taking resources from other people, like conquering neighboring lands and stealing their serfs. And we're moving from that world into a world in which you get more resources by creating value for others. It's better to do the thing that creates value for others and be a good person to work with, such that people want to work with you in the future and provide more opportunities. And the best startup founders he knows are very nice, good people. However, a lot of the things about the way the world works are still rooted in older ways of doing things. This is why people build products and service companies that optimize for short-term revenue over doing the right thing by their users and increasing value created for users and profits for the company. For example, the company that we built and sold was a direct-to-consumer subscription e-commerce SMS management tool. Subscription e-commerce is a big growing thing. People get subscription coffee, protein bars, and whatever else. The perennial problem is once you signed up for one of these things, eventually you have too much of the thing. What we built allowed you to manage your order via SMS. You never did any promotional marketing stuff, pushing anything on you. It just made it so that from when you first signed up, it made it super easy to change your order or skip a month or whatever. And what this wound up doing is substantially reducing short-term revenue for the companies that used it, but also substantially increasing lifetime value of customers. It's interesting how obvious this is, but people are inclined to leave a lot of value on the table because they're not inclined to do things like this. When we were first doing sales for this startup, potential customers would respond one of two ways. They would either say, this is awesome. Of course I want to sign up for this and have my users get the right amount of the thing that I'm making for them and passionate about putting out into the world. Or they would be like, I don't know about that. I don't want my revenue numbers to decrease. That's not going to look good to my investors. It's a very stark difference which of the two approaches you would get. And honestly, if we were a lot bigger, instead of being acquired, I would have acquired the company that acquired us and then used that litmus test to evaluate whether or not to invest in these direct-to-consumer subscription e-commerce companies. This is sort of core to our DNA, has been fairly good for us. And incidentally, also for people thinking about starting alignment-driven organizations, nonprofits or for-profits, I think if they start out mission-driven and don't compromise on that and only bring along partners who are aligned with that, it makes it a lot easier to do things all the way along. And it does lead to the creation of bigger opportunities in the long run as well. The company came after the core values themselves, and they allow for a lot of this stuff. We're very big about starting small, but then taking acceleratingly large A/B tested baby steps. That allows us to go into new things that we have no business doing because we can assume we're going to be terrible at it first, but with a growth mindset, we'll get better and better over time. The self-efficacy beliefs that ensue from having done that a little bit yield the ability to do substantially more and more ambitious things. And I think people tend to overestimate what they can do over a short period of time and underestimate what they can do over a much longer period of time. We set out to do very ambitious things. We set originally like this 10-year big, hairy, audacious goal with a goal about the consulting business and the skunkworks companies and the BCI stuff. And we wound up actually achieving that whole thing way sooner than we could have guessed. And then we made that all the more ambitious. We thought it was unlikely to happen, but we could do one or two of these things. Ideally, if we can do the third thing, that would be great. Let's first perfect the consulting business, then start to do the skunkworks, then start to do the BCI stuff, and now the AGI alignment stuff. Interestingly, in the very beginning, I set out to do all of them simultaneously, BCI, skunkworks, and consulting. I did a terrible job of all of it. It was okay enough, but it didn't work. Then we went back over time and perfected, did one really well, and then set that off the run quite effectively with the right external structures that things work way better. And I think we were also quite interested in building things that are sort of like in a cyborgism type way, an extension of oneself. As a result of the things we built internally, I am probably 100 times more productive in a single day than I was when I started the company. It's great to be constantly thinking about stuff like that as you scale an organization and investing. We have a lot of the best developers and data scientists in the world, and we're always investing in things to build and use for ourselves to improve the quality of our lives and increase our agency.
Hey, we'll continue our interview in a moment after a word from our sponsors.
Today's episode is brought to you in part by Weights and Biases. As a developer, the journey from concept to production-ready large language model apps is fraught with challenges. Dealing with unpredictable large language model outputs, correctly handling PII, and ballooning API costs can all be blockers to shipping your next AI-powered feature. Weights and Biases Weave is a lightweight AI developer toolkit designed to simplify your large language model app development. With Weave, you can trace and debug input, metadata, and output with just 2 lines of code. Weave helps you run rigorous evaluations and securely manage all of your datasets and system configurations, so you can focus on what matters most, iterating and improving on your large language model-powered applications. Plus, Weave integrates seamlessly with your favorite APIs and libraries, including OpenAI, Anthropic, Mistral, Cohere, LangChain, Llama Index, and more. So make real progress on your large language model development. Visit w&b.me/cr to get started with Weave today. That's w&b.me/cr, and thanks to Weights and Biases for sponsoring this episode. I am really excited that our new sponsor, 80,000 Hours, is now offering free one-on-one career advising sessions to Cognitive Revolution listeners. 80,000 Hours aims to be the best source of advice for people who want to do the most good that they possibly can with their careers. We typically work for about 40 years in our lifetime, and we work about 2,000 hours per year. That is the single biggest opportunity that most of us have to make a positive contribution, and it's worth being strategic about it. That's where 80,000 Hours can help. I actually used their career advising service myself. 2 years ago, I had just finished the GPT-4 red teaming project, and I wanted to do anything I could to nudge the AI future in a positive direction. But what could or should I do? That was not clear. After my call with 80,000 Hours, I got a number of connections to outstanding individuals in the space, and over the course of the follow-on conversations, I developed confidence that this podcast was one of the projects that I should pursue. Today, I'm thrilled to have built an audience of thoughtful, high-potential people that 80,000 Hours wants to help. To request a free one-on-one career advising session, follow the link in the show notes. It's 80,000hours.org/cognitive revolution. That's 80,000hours.org/cognitive revolution. Sign up for a free one-on-one career advising session, figure out how you can make a positive impact on the AI future, and I think you'll be glad that you did. Okay, I'm going to have to be disciplined in my follow-up questions. Long-term thinking has come back in fashion. You're a great, example of setting out with that mindset. Hiring people with a mission-driven orientation is commonly received advice, but easier said than done, especially if you're sort of like, our mission is to solve the AI alignment problem, but your job is to build this SMS tool for subscription management. That's where I see a lot of these things, not even necessarily with goals as ambitious as addressing AI alignment, but even just on a more conventional level. Oh, we'll do technology consulting, and then we'll make our own products and apps, and we'll kind of also be a startup. That typically doesn't seem to work. People kind of just get consumed with the consulting. People have to do a good job on these projects, right, for the whole thing to go. How do you, from a leadership standpoint or a culture standpoint, how do you get people focused in on the sort of foundational tasks, that maybe the less sexy tasks that everything else depends on, in a way that keeps people happy?
Yeah, absolutely. I don't think they are less sexy. They're interesting technical problems to be solved. The brightest, most ambitious growth mindset people can get excited about whatever that might be. I genuinely am excited and care deeply about every single one of our client projects and think they're awesome and want to do everything I can to make them succeed. We've scaled the organization in such a way that I can have a positive impact on them, but also trust really great people to be fully focused on them. But originally I was fully focused on them, and that was all I did. At the very beginning, because we're a profitable bootstrap business, I also rented our office on Airbnb. I remember my partner on the first day he started, a Dutch tourist stepped out in a towel and asked him, "Where's the bathroom?" He was completely shocked. In any case, you might be the brightest machine learning engineer in the world, and you might be the person who thinks of the thing that ultimately solves alignment. But you still have to do the dishes sometimes, right? And you might as well enjoy yourself while you do that. The things that we do are way more exciting than doing the dishes. They are legitimately exciting in and of themselves. The better job you do with it, the better job you wind up being able to do with everything else. Because we're a growing company with a lot of opportunity doing more and more ambitious things over time, there is unlimited opportunity for individuals in the long run to grow into various different things. Basically, if you are what we call a good tripper, you do the right thing and take on more than your own fair share, and you're willing to push yourself when things seem difficult. This comes from me having led wilderness trips for many summers in Wisconsin and Ontario, where you take a group of kids who would be sort of not necessarily beforehand any experience doing difficult wilderness trips. And then by the end of the trip, we would engineer an atmosphere in which it was cool to be a good tripper, do more than your own fair share, to carry the heavy pack, get into camp, realize that tents need to be set up, vegetables need to be chopped, and water needs to be purified, and do that without being asked. Push yourself to carry a canoe farther than you think you can when you thought you couldn't even pick it up. There's no better feeling than throwing the canoe off your shoulders into the next lake. In life today, people often coddle themselves too much, and then they don't wind up getting the super rewarding feeling of throwing the canoe off their shoulders into the next lake. But if you do push yourself in different ways, then you can wind up achieving bigger and more rewarding. And I think people who wind up being good trippers on whatever they wind up doing and creating the maximal value they can for our clients, or in the Skunkworks company, they're the people who are going to have the biggest positive impact in the various other things that we do and have a bigger positive impact on the world. Two, one fun little hack that we set up. Actually, my wife, who's our CTO and far smarter than I am, set this up. We donate 5% of our profits to effective altruism charities, typically a shorter term, not longer term things. So I tend to push for them to be longer term things, like malaria nets. Every hour you work on some annoying bug that's a billed hour to a client, you wind up donating 5% of the profits of AE to save lives, which is intrinsically motivating, I think. And that's been pretty awesome. We have a lot of other little things that add up to make it such that people can feel motivated on a day-to-day basis. But the reality is sometimes there will be things that are quite difficult and challenging and not motivating in whatever work you might be doing, whether it's working on alignment or some client project or whatever other job you might do. I do think that people starting nonprofits and for-profits doing AI safety can have the mission of doing something for AI alignment. That itself is very important and potentially quite urgent. It would be great, for instance, to nerd snipe a lot of the brightest startup founders into making their startup have something marginally to do with increasing probability of AI alignment instead of just advancing capabilities. It would be great to get successful founders who are trying to figure out, okay, now I've made money, but what's the meaning of life, to do something impactful for the world and advance AI safety at its core. There is a scarcity of people who just get stuff done. There are a lot of great people who get stuff done, but there are not enough people in this field. And it would be great to have more people who I can execute, run organizations, and work on more neglected approaches to AI safety.
That's all fascinating. 100x more productive position today as opposed to when you started. I often say, depending on the exact task, I think like a multiple more productive with AI tools at my disposal today, but I'm definitely not 100x more productive. So I want some of that. Give me a little flavor for how you have achieved that.
Yeah, absolutely. There is quite a lot of different stuff that we do at the company and that I do on an individual level. But I would say the single thing which alone has made me 100 times more productive, because it's made me at least 100 times more prolific. The things that are able to get out of my head now go to execute in various ways. The company is a specific tool that we built, which is sort of a launcher. It's called Universal Launcher. It's really mostly customized for people at our company, though others can't use it. But you can download it on universallauncher.com. But basically, the idea is like, there are limits to your working memory. Previously, I would be doing something and I think, oh, I should do X, or I want to ask my assistant to schedule a meeting. Then I might have to open up Slack and message them and be like, would you mind scheduling a meeting with this person at this time? Or I open a Trello card to have us discuss X, Y, and Z, and I have to open my web browser and open a new tab, type in Trello.com, wait for it to load, select the right board, and go to the right column. Basically, as a result of the limits of working memory, there's an increased probability that you're going to lose the full context of whatever you thought of originally. This, I think, is one of the greatest injustices of modern humanity as it exists today. I wouldn't be surprised if future generations look back on us and be like, wow, those people could never think complete thoughts. And that's like a terrible travesty up there with other great inhuman things that had to exist. But in any case, it also can just make you a lot more productive with a single command. I press Command Spacebar on my Mac, or on my phone, there's this little button, the U button. I can push that and it goes straight to the launcher. Then I can add to-do items to my own to-do list, or for other people, or to different boards to talk about X with our CFO, or ask my assistant to do Y. Interestingly, I use this, as do most other people at our company. It's remarkable how much more productive it winds up making you. But also particularly, like, one thing that's pretty exciting about it is that you don't have to use Universal Launcher to have this effect. You just have to capture the ideas. But the fact that I know I can capture the ideas and I trust the external structure that they will wind up getting executed with like high probability of success, because historically they have been, that means that I'm way more likely to capture way more ideas than I otherwise would. That's pretty liberating, and it winds up making me think of much more interesting new ideas, initiatives, and solutions to various different things. I can be reading some random paper and then think, this is really cool. I should have us look into this particular neglected approach, and then capture that, and it actually winds up getting done. Pretty amazing and awesome. I think the optimal end user experience of an individual, like using technology, eventually will be something closer to that, but also having AI agents wind up implementing various different things that you'd want done more fully. And we've built some parts of that into this tool as well. I think the thing that has made me the most productive is the fact that I can get more ideas out faster. Instead of holding in my head, I have to do X. When it's no longer held in my head, I can be fully focused on whatever the other thing is I'm doing. And I think a lot of the time people lose agency. You might be working on some super complex technical problem, but then you see a missed call from your cousin and you're like, oh, I should call that person back. Then for the rest of the day, you might be multitasking between, oh, I got to call that person back, and trying to hold all this random complex stuff in your head. You're not going to hold it in your head as well, and you're not going to solve the problem as well. The solution you come up with is going to be substantially worse than you otherwise might have. So just being freed up to think more deeply in a way where you're totally present in what you're doing, but also you can trust that whatever other distractions come up get put into the right external structures to deal with, I think has been quite liberating for me. And then we've tried to build structures like that throughout the company for other individuals to be able to capitalize on the same thing. Like, Mike, what is your experience with Universal Launcher, for example?
One of the things that's interesting is all of the integration. Judd was talking about Slack and Trello, but there's lots of integration. But it's a matter of idea to muscle memory to capture, going from idea to muscle memory, and now it's captured and you can release that idea and move on, is actually a huge productivity gain.
What I think is fun about
universallauncher.com. I'm on the website right now.
Mike, you worked at AE for years before you used Universal Launcher. What changed? How is life different as a result?
I can't imagine not using it anymore. It feels like an extension of myself in a way. It's muscle memory to do it. Going through UI to try and capture an idea and then all of the distraction and how long that takes versus just capturing it immediately. I had an update and I had broken something with it at one point with the install. It wasn't running. I felt like I couldn't use my computer correctly. My muscle memory wasn't working, and I had to relearn how to do it the old way temporarily. So, yeah, it's really a powerful thing.
There is a steep learning curve.
That's true. I think one of the reasons I didn't use it for many years is because there is a bit of a learning curve. It's a little bit like learning an instrument. So, yeah, if you're willing to go through that learning curve, the payoff is huge.
One thing that's very cool about Universal Launcher, I think, is that this is just one example of a thing that substantially increases our agency with technology and makes being human better. We're on technology all day, day in and day out. And this thing fundamentally solves a thing. Like, you take out your phone to do X, you see a bunch of push notifications, and then you're like, why did I pick up my phone in the first place anyway? Instead, we take out our phone, push one button, and go straight to do the thing and don't have to deal with the push notifications. We don't want to do it. I think that this sort of thing, though it's less obviously something that solves alignment, these things are going to be increasingly important in the future as we have AI taking over more and more things. It's going to be important that we understand the way the human brain works and then build end user experiences that increase human agency and improve the nature of being human. There's low-hanging fruit to build stuff like this, but just as nobody sets out to build profitable bootstrap businesses with big visions and long-term missions, people don't set out to build technology products that have steep learning curves and no clear plan to get revenue models just because they want to use the thing to increase their agency. And as software gets cheaper and cheaper to build, it's going to be pretty great that people can invest in things that substantially improve the nature of being. Universal Launcher makes my life experience way better. I can't tell you how much better it is. I enjoy being me as a result of this. This is just the tip of the iceberg in terms of what people can create. The more stuff like this that people create, the more productive and happier they will be to better solve the alignment problem and other problems too. People could also do startups to increase agency and make alignment researchers happier and more productive.
The way you guys talk about the muscle memory involved does lead into thinking about brain-computer interface. We now have Neuralink with an implant in a couple of individuals' brains, and the way they describe their experience is, very much this sort of muscle memory type experience where they're learning to use this interface and they have to develop a new skill, even though it's all mediated by that implant. How did you think about the brain-computer interface problem? Do you think about it similarly to how Elon has talked about it, where he talks about increasing the bandwidth between the computers and going along for the ride with the AI era, or perhaps a different foundational way of thinking about it? I'd love to hear about some of the most interesting projects that you've done in that space over the last few years.
Yeah, absolutely. Well, the original motivating factor with regards to alignment and BCI was less being able to keep up with AI and more making humans smart enough to solve the alignment problem in the first place. There is a possibility we might be able to keep up with AI via BCI, but I don't think it's a very high probability. So it seems somewhat wishful thinking, but at the very least, we'll be able to go faster and think better, and that'll be pretty nice. But I do think there's a lot of opportunity to just make us smarter to be able to solve the alignment problem in the first place in a world where we get basically unlimited funding going towards alignment, which I do think is actually entirely plausible. Everyone suffers from exponential slope blindness, and that does not predict the future particularly well when it comes to things with exponential slopes. We might wind up finding ourselves in the low single-digit number of years in a world in which there is effectively unlimited funding for alignment, and nobody knows where to put it. The world might start to say, we spend trillions of dollars globally annually on defense. We should spend at least that much on the biggest threat humanity's ever faced. The people who could do meaningful things to advance alignment are sorely unprepared for a situation like that. BCI in particular is one area in which you can invest a great deal of money and potentially have huge, huge impact when that does come about. So especially if you get truly automated science that doesn't kill us, and not just automated AI, but also various other automated things in labs and Tesla robots. That's entirely plausible. Decades of BCI progress in the space of a year or a month. Of course, there are limitations because it requires human patience generally, but there may be ways around that in terms of the biggest innovations that need to be made. It's very much a neglected approach in a larger portfolio of bets, which works best in that scenario. I think that's most promising. But then there are other things that work there too. Mary and others around Cone are quite excited. They invested in the human intelligence augmentation, gene editing for human intelligence augmentation startup, which could make a big impact. But specifically with BCI, the original thinking was that we wanted to, without profit motive, build open source BCI operating system, Linux style, which would enable the development of multimodal BCI systems that would increase human agency and human flourishing. We started with originally a guy who now is the CEO of a FRO doing ultrasound. It was an AE client doing machine learning. He helped us kick off our BCI initiative when we had no idea what we were doing. Our original forays were sort of embarrassing, but we figured out what we were doing with him and got involved working with top labs around the world, doing various new ML methods to accelerate BCI development. A motivating factor was that Facebook, Meta, and Google were really involved in developing BCI, and we didn't like the idea of them owning the extension of our thoughts, as I said before. So without profit motive, trying to build maximally agency increasing BCI, one thing that started to put us on the map is that we participated in this prestigious neural latent benchmark challenge, which was started by Chathan's lab at Georgia Tech. And we used state-of-the-art neural models combined with various advanced ML techniques to win that challenge. We worked with labs doing advanced BCI, like BrainGate, which had been at the forefront of BCI systems, and also focused on finding tools and methods that could be shared across different labs to accelerate their research, and collaborated very closely with them to develop a bunch of different interesting open source projects and got some grants to do so as well. Those things include a neural data simulator, which worked with an awesome collaborator named Chad Boulay and enables BCI development without a participant in the loop. Another one's the neural NDK, the NeuroTech development kit, which we did with a guy named Quentin and another guy named Millen, who are both doing very cool things in this space now too. New neuro data standards for things like NWB, which is Neuro Data Without Borders, brain imaging data structure to facilitate better data sharing across groups, and privacy preserving ML methods for neural data to improve user agency and privacy, doing a bunch of different blockchain stuff and distributed learning systems, which we applied to BCI using techniques like federated learning and homomorphic encryption. After doing all of this for the community, we started working with leading BCI companies. We worked with BlackRock NeuroTech, which makes the Utah array the first FDA-approved implanted invasive electrodes, with Forest NeuroTech on their minimally invasive ultrasound systems that let you get 1,000x more data out of the brain than you could previously do, and also supported work and are excited about work being done by various other BCI adjacent startups like Journey, the Jhana meditation company, Stroke DX, and others as well. Basically, a lot of our work is neuro-inspired. We want to do even more neuro-inspired work. And we still have great talent in neuroscience and BCI on our team. We are focused on doing whatever the highest impact neglected approaches are. So we're doing increasingly things that are not BCI related necessarily in the short term, but also various neuro-inspired neglected approaches. I think there are a lot of great neuro-inspired neglected approaches that can be done.
Hey, we'll continue our interview in a moment after a word from our sponsors. Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
Let's kind of just zoom out and give like the high level view. Where are we in neurotech or brain computer interface right now? Where do you think we're headed over the course of how many years? Why do you think that is too long to wait and ultimately forced you to, I don't know if you would call it a pivot or refocusing, but you've changed your strategy. So interested on, kind of your vision and what made you think that vision is just not one that you can afford to be patient enough to see through.
Yeah, if you think about BCI, there's lots of hurdles towards making progress. You see things with but even with Neuralink, which is maybe state-of-the-art, BlackRock, who we worked with, state-of-the-art in terms of invasive BCI and high bandwidth methods, there's still some fun, even just getting FDA approval. It's a very slow iteration cycle. Struggling to decode arm movements or getting cursors to work, keyboard decoding or something like that. We're not there yet. So The timelines from going from that to increasing human intelligence to a point to help solve alignment, for example, or even the BCIOS and having BCI be an extension of human thought, that timeline is much longer. And so if you think about AI alignment and AI safety and what timelines look like there, and we want to do the most impactful thing, you know, it's not that BCI isn't a worthwhile pursuit, and of course we're still doing neuroscience inspired approaches, and we still have BCI work. But I think the fork there is clear that if you want to do the most impactful thing, then AI alignment for us, especially taking some of our background and applying it there, this neglected approach, it can have a bigger impact in a shorter amount of time than that very long-term audacious goal for BCI.
And just to be concrete, what do you think that timeline is? Do you have a sense for when a Neuralink like experience, perhaps not a Neuralink like device, but a sort of I can augment myself with some new thing that allows me to interact with computers purely through my thoughts and in a way that, you know, kind of becomes second nature? How far off do you think that is from being something that is like a consumer device that is commonplace because it's super useful?
I mean, I think that's a very difficult thing to answer because of the exponential slope blindness thing. Any response that is too soon would make anyone in NeuroTech think, people with neuroscience backgrounds be like, oh my God, you're crazy. But, you know, Elon Musk and others have outperformed expectations in the past, and AI is certainly accelerating everything a great deal. But even still, with that said, like we did conclude that the thinking that set us down this path of doing more other neglected approaches was something like for BCI to get to the point that we'd really like it to certainly substantially accelerate AI alignment. That's maybe at least 30 years out. That was what we discussed internally. We said, okay, let's do other stuff that can be higher impact over a shorter period of time. With that said, we still want to push that forward as much as we possibly can. I think it's good if you can afford to do so, have a portfolio of bets over various different timelines. People spend too much time thinking, oh, we can't do this because of this timeline or that because of that timeline. But it is worthwhile for people to work for a prolonged period on an approach. Realistically, your timelines will change over time, most likely. People's timelines wind up updating way too much on recent news, just as people update way too much on the probability of one presidential candidate winning or the other based on the most recent news. The unfortunate thing about approaches over longer timelines is that people are more likely to abandon them because they start to think about shorter timelines. So I do think it is important that people with longer timelines or good ideas for things that require longer timelines continue to work on those neglected approaches, and that funding is allocated to those, like people think about the most impactful work that would take decades and then actually go set out and do that and think about the multiple big ambitious steps that need to be taken and then execute them one by one, and also focus on the biggest unknowns that you have to de-risk that are going to take the longest period of time if you can afford to do so.
So if I understand the narrative history, you had the neglected approaches idea for a long time. The brain-computer interface work was one neglected approach. You're climbing the mountain, getting over your initial failure, starting projects, actually getting to the point where you're working with real leaders in the field, winning, prizes yourselves, making meaningful contribution. And then I think this is pretty recent. My sense is like in the last 1 to 2 years, sort of realized like, geez, this stuff is happening fast. Maybe we don't have time to climb this full mountain. And then from there, we need to resurvey the landscape and figure out what currently are the neglected approaches and which ones do we feel like we can tackle. And then from there, you actually went out and did a survey of the field to try to get a systematic handle on that. Tell me about the survey and what you learned from trying to figure out what is common and what is neglected today.
Absolutely. That timeline is generally accurate. With the survey specifically wound up happening to confirm a lot of the hunches about neglected approach stuff that we had. We didn't set out to do that and had no idea what to expect. But the survey came about as a validation to a meta approach of trying to figure out the highest impact things to do. We learned that alignment researchers don't think current AI safety research is on track to solve alignment in time. They also don't think that current approaches cover the space of plausible research agendas necessary to solve alignment. And yet, what do people wind up putting the most time and resources into? These things that are not likely to solve alignment. Like, two biggest things being mechanistic interpretability and evals, which of course we think is very good to do that work and quite important. And there are also neglected things within both of those things. And we're working with Goodfire AI, for example, as a client, doing awesome mechanistic interpretability work there. And we're very glad that they're doing that. Interestingly, even though people realize that it's a particularly neglected thing they set out to do, I think they herald a new age of people building awesome AI safety driven startups that are really mission driven first and foremost. With the general research being done across the board, people realize that we should do other neglected approaches. It's good for your career, or you're more likely to get funding to do something where you can make more progress. There is a lot of low hanging fruit there. People just think that we should do something. I think that made more sense in a world where you have unlimited timelines and it's more of a greenfield, like the way EA used to be. But the reality is, when there is a possibility of short timelines, then you just sort of have to do whatever it takes to make the thing work. The survey results indicating that people don't think we're on track to solve alignment in time, that the space of current approaches does not cover all plausible research agendas needed to solve alignment, seem to indicate that we should spend way more attention and resources pursuing neglected approaches to alignment, in addition to any other practical steps that make alignment research more likely to solve alignment before we get AGI. It's great to see that people are realizing this more and more, using this term more and more. Most alignment researchers don't actually view AI safety and capabilities advancement as mutually exclusive, but they assume that other people will, which is unfortunate. There's often a disconnect between what individuals think and what they think everyone else in the community thinks. When we first started to get into alignment a year and a half ago, we encountered this pushback about advancing capabilities. People were often scared to take any action or even think about doing something ambitious to solve the alignment problem for fear of advancing capabilities generally. One thing that most people realize, at least on some unconscious level today, is that capabilities are moving forward super fast, regardless of what people who care about AI safety are doing. I would prefer to live in a world in which we get BCI right before we invent all this stuff, and where we understand what consciousness is before we invent all this stuff. But we don't. The full economic forces of the entire world are behind advancing AI capabilities right now as fast as they can. And I think we have to recognize that that's happening. Therefore, we should try to solve the alignment problem. Ideally, they don't do it too much, but there's also interesting work out there around doing things which are sort of like a negative alignment tax. I think that's a pretty exciting thing too, like doing things that increase the probability of actually solving alignment while also potentially, like, you advance capabilities a little bit. The assumption, though, is that anything you do that makes AI more aligned is going to wind up reducing its capabilities. But we haven't necessarily seen that historically. What if we live in a world where it turns out that you sometimes advance, where it's possible to advance alignment and then be more capable by virtue of your alignment? That would be preferable if that is the case. Maybe it's not the case, maybe it is. We shouldn't over-index on that being the case. But if it is, that would be great. It would be great to find and do more neglected approaches that support and explore that possibility. Regardless of the fact that AI capabilities are off to the races, like the marginal impact of some people working on AI safety, doing a little bit to advance capabilities is orders of magnitude less than would otherwise be done. You might as well do stuff that winds up advancing alignment if you can, while still being responsible and having good safety plans and things like that. I guess other things that are interesting from the survey are that both the effective altruism community and alignment communities overestimate the perceived value of intelligence in the community and underestimate the value of softer skills like collaboration and work ethic. As soon as anyone hears, they're like, oh yeah, of course that's the case. I think there are pretty big implications there in terms of if you want to be more effective and have a bigger impact. Historically, a lot of people who might be super needed in organizations for advancing AI alignment were turned away because they weren't math geniuses. But people with these softer skills are very much needed to make organizations run more healthily and succeed better. And I think there's a lot of need for that and low-hanging fruit.
But you're saying that the community as a whole recognizes that they're needed, but still individuals within the community don't think that recognition has happened. And so people presumably with those skills are sitting thinking, well, they won't want me because I'm not a math PhD.
Yes, exactly. Those people are enormously needed, and often the sorts of people who can help grow organizations. Imagine the idea that we might wind up having unlimited funding in a low single-digit number of years. But if we do, I think it's essential that every alignment organization has a good plan for what to do and how to scale in a healthy way that doesn't grow too big too fast and do the opposite of what they should be doing. In those situations where that does wind up happening, and I do think there is some chance that happens, we should be prepared for it. You'd want to have way more people with these softer skills to help grow these organizations in healthy ways.
Yeah, people should definitely make note of that. Let's get into the recent papers that you guys have put out, both of which I think are super interesting. Your current approach to AI alignment. At the end, we can zoom out a little bit and talk meta, and you can offer some thoughts for others who might want to develop their own approaches. The approach that you guys have taken, you can give it the proper title, but the way I understand it is biological inspiration, not just at the level of looking at a neuron or a circuit, but zooming out and looking at bigger phenomena in biological systems and thinking like, what if we ported those over to machine learning systems? What would that look like? And I think if these first two results are any indication, this is a super promising line of inquiry. The two are self-modeling and self-other distinction minimization. And we'll unpack both of those in detail. I don't know if you want to give any sort of high-level motivation at the background in brain-computer interface, so that puts you in position to think along these lines. But then I'm really excited to get into the real details of both of these, because they both jumped off the paper to me as like, wow, more people should be doing this. Why haven't I seen this before? It seems like versions of this have a home in the systems that I expect to predominate in the future. So I was really impressed with the work. Give me a little more motivation for it if you want, or we can dive into self-modeling.
I think that motivation you described is basically accurate. One important point to add is that we are taking this larger meta-neglected approaches approach. We're trying to find neglected approaches as best we can and encourage them as best we can and do whatever the highest impact ones to do are. And one part of that also happens to be finding individuals with really great ideas and hunches for things who are not sufficiently supported and making their dreams, things which are individually unlikely to work with very high impact. If they do a reality, we are good at evaluating those sorts of things and making them more likely to happen, because this is what our client work does. In our client work, the client is the product owner, and then we are the technical team implementing all the technical work, but also we're managing it and trying to figure out the highest impact stuff to do to actually make the vision a business and technical success. The client is not accountable for managing or implementing the technical details themselves. That turns out to lend itself very well to finding and working with a good track record of knowing when clients come to us. I have a pretty good sense of how successful they're going to be from doing this for many years now. I think there's a fairly similar thing for finding individuals with neglected approaches, evaluating them and setting them up for success. So in this case, we did do those two particular things. This is a model that's a very neglected approach, which we would like to see scale substantially, build out better ourselves, scale it more, and then get as many other organizations around the world as possible to copy it. If we wind up living in this world in which there is unlimited alignment funding, you want to solve the talent gap as much as you can, getting impactful people to work on alignment solutions. And I think Ryan Kidd and Matt's have this great Less Wrong post about the 3 different types of alignment researchers. There are people who are going to be more likely to come up with really good alignment ideas, but they don't necessarily have the capacity to fully implement the whole thing. In an ideal world, we would be setting up perfect external structures to maximize the output of the most brilliant creative people thinking of neglected approaches to AI alignment, and then also have great structures and teams to support them and make that thing happen, and have effectively unlimited grants making that happen, unlimited grants, and eventually there'll be good ideas for this that are for-profit companies as well. If you start from a place where there is unlimited funding and think about how have we solved alignment given unlimited funding, then you want to optimize the creation of these ideas, and the unemployed autistic people with crazy ideas who say something on the internet and no one listens to them and they don't have the social skills to sufficiently communicate might be one of the essential elements in solving alignment. We'd like to systematically find those things and then build the best possible implementation for it and see if it works. Right now, we only put the profits of our company into the alignment work that we do. Having taken external funding, that's core to how we think about doing things to retain agency. We're not opposed to taking grants in the future, but basically like what we'd like to do in an ideal world is have this scale and do way, way more work like this. And then you can have the most talented, competent software consulting organizations in the world copy us and do this instead of building other random crap. And not to say the other random stuff is not valuable, but as many people as possible could be working on actual meaningful alignment work. A thesis we had was that senior AI engineers with no previous background in alignment could quickly get up to speed and do very meaningful, impactful work. We've proven is the case. If anything, more productive than your average alignment researcher because they do technical work all day instead of just reading. Like it's a thing that can scale way more, I think. And it's worth that eventually happening in various different worlds. That's another thing people can do and should do. Start consulting organizations. There's consulting organizations to do other people's alignment. That's one way to bootstrap a thing into being a bigger, impactful alignment organization in the future as well, and eventually develop its own ideas. But I think that's a really good thing with both the self-modeling and the self-other overlap stuff. There were two brilliant individuals who had these neglected approaches, and we've made them both happen. The self-modeling one was an awesome professor at Princeton named Michael Graziano, and our work in self-modeling is inspired by his mechanistic theory of consciousness, which we can also get into. It's pretty interesting and awesome. But there are two or three really interesting high-level things in terms of motivation and what our results are pointing to so far. Self-modeling may be the architectural change that results in conscious AI, which also validates Michael Graziano's mechanistic theory of consciousness in some cool ways. We think that self-modeling is a strong prior for cooperation, so it may also be an avenue to bias AI systems towards cooperation. We found that self-modeling induces a simplification of the network. This has potentially profound implications for neuroscience, psychology, and machine learning. For example, we've been working with John Barge, who did some literature review and reached out to colleagues in his field and has the opinion that there has been no former connection between self-modeling and simplification in psychology literature. We've stumbled upon something pretty major here. From a pure machine learning point of view, our implementation is actually pretty simple and elegant, and we can get into the details too. But for now, basically, this means that it's trivial to add to pretty much any neural network, both from implementation and training costs perspective. It's not that expensive. Even though we still have a lot to understand about self-modeling, it may turn out to be a state-of-the-art training technique, which would have profound implications since we would be teaching the model to do self-reflection and provide a neuroplausible mechanism for consciousness in these artificial systems.
Let's go one level deeper. You guys can divide it up how you want. Often I try to give the setup, but maybe in this case, Mike, you should give the research setup. That's very high level, lofty stuff, but it does translate to a very practical, intuitive, experimental structure that is honestly not that hard for people to wrap their minds around. That is part of the magic of this paper that attracted me to it. So give us the low-level details of what you set up and what you found.
The setup is, as Judd said, extremely simple, elegant. An undergrad could implement it and test it. So, and that's part of the appeal. We can start at the low level. We'll eventually connect it back to the neuroscience and where it was inspired from and the motivation more directly. At a low level, what we do is train a neural network and add one extra output layer. For your technical audience members, you have the activations of the penultimate layer. They typically go to an output classification layer that tells you what to do if you're doing a classification task. And so we just route those activations to another layer that says, predict these incoming activations. You could choose different targets in the neural network, but we chose for the paper, the one that we're reporting is the one where you model those incoming activations. And so you just add another loss function that says, do your task, but also predict yourself. That's the entire setup. And then we measure what happens when we train like that.
Yeah, I think that makes sense. It's a theme for sure that clever modifications to a loss function can bring us great benefits. This is another instance of that where it is remarkable. There's now two elements to the loss function, right? I think they're just literally added together, right? So you've still got to predict. Your job as the neural network is still to predict the number, and you're using MNIST, like the classic handwritten digits. So you still got to do your job, but now you have this additional term, which is you also have to predict what was the state of the layer before
essentially the middle layer, because this is a pretty small system that you're going in such depth on. And now you've got to do both. And it turns out you can do both, but interesting things start to happen when you do.
Yeah, that's right. So, in some sense, you give the network the task, predict your internals. And so what can it do? It can learn to predict those well, but it can also make the internals easier to predict because it has control over that, right? It's intuitive that the learning process would result in simpler internals. We said that might happen. And then the thing to test is if you end up with simpler internals, can you still perform the task, right? Like, does self-modeling just derail the training process or not? And it turns out it doesn't. So we don't lose any performance. But what we see is self-modeling, you get simplification across a couple of different metrics. And then not only that, but when you turn the weight up of the self-modeling loss, so you say, this is actually more important than your task, what you find is it's still very good at doing the task. This is MCFAR and IMDb classification. Across all three tasks, 3 different models, 2 modalities, you see the same trend that when you turn up self-modeling loss, you get simplification and you don't lose any performance. So that's the major result. I think the interesting thing here is how it was motivated and how it ties back to the neuroscience aspect. It's motivated by this theory of attention schema. Our collaborator, Michael Graziano from Princeton, is a neuroscience consciousness researcher, and he has a theory of attention, a mechanistic theory. And it's based on self-modeling, and people have different theories of consciousness. But it's intuitive, and it makes predictions about what should happen. That's where the motivation comes in, based on self-modeling in the brain. What if we do this very simple, elegant version of self-modeling, and then see simplification and interesting connections back to neuroscience?
We've done one recent episode on kind of broadly speaking possibility of consciousness in AI systems with kind of a rundown. When I get to the attention schema and other similar things, there's information integration theory, which I put in the same bucket of fairly materialist mechanistic proposals. I find them to be interesting. I can't quite make the leap where I'm like, how does this solve the hard problem? This might make mechanistic sense. I can much more readily tie it to behavior. That's probably all we can really say about the system or the models that you guys have trained. I am interested in if you have a formulation of how that leap gets taken to how I feel things. Like that I'm not quite getting over on my own. I'm interested in the attention schema, particularly in how we make the leap to subjective experience there, or why we think this is more than a mechanism and actually the source of consciousness. And then really interested in developing my own intuition for the complexity metric that you used and what we understand about the simplification we're seeing as a result of this self-modeling mechanism.
One thing that's pretty interesting here is that the self-modeling task biases the internals of the network to become more predictable. Our results show that these networks, while simpler and more parameter efficient, don't lose performance. Keep that in mind as we talk about attention schema theory. Attention schema theory, for some reason, is hard to get through your head. Once you deeply get it through your head, sometimes your brain just sort of rejects it afterwards. And you're like, oh, I totally get it now. And you're like, this makes sense and completely explains consciousness. Then the next day you're like, wait, no, that doesn't make sense. It doesn't explain the quality of stuff. For some reason, this winds up being the case, which is unfortunate and makes this be, unfortunately, a neglected approach, which people are not funding enough. If anyone's listening and wants to send funding to Graziano's lab, they would very much benefit from it. Even though Graziano is a brilliant researcher with past successes, people don't like funding his consciousness research because it's too mechanistic and not magical enough. But even if you believe in magical theories of consciousness and not mechanistic theories, you still might as well understand reality. You can layer in your pretend magical stuff later on. The reality is we don't understand enough about consciousness at all. We need to make a lot of progress to better understand reality. If you want to better understand things and have other theories, it would be worthwhile to make way more progress. There's so much low-hanging fruit of awesome stuff to do that we see right here, and Graziano does too. Basically, the fundamental idea of attention schema theory is that it has proven useful and made accurate predictions about what would happen in artificial agents, which seem to be enormously impactful for alignment, which at the end of the day is the main thing that I care about, rather than getting lost in like things that we don't sufficiently understand scientifically and people want to debate forever. Might as well just be concrete and progress. Attention schema theory suggests that in the same way we have a simplified model of our arms and legs, we also have a simple, imperfect model for our attention. A model that includes how we take and process all sensory inputs within our brain and what our goals are, whatever we're paying attention to. So like body schema theory, if you've ever seen those videos where there's a guy with a fake arm in front of him and someone hits it with a hammer and his real arm on the side suddenly shoots up from under the curtain, or if you're familiar with phantom limb syndrome, these are examples of where the body schema, your body's imperfect model of your body, conflicts with your actual body. It's important to note, you can't ever actually know reality. All you can know is your imperfect models of reality. That's the reality. You have an imperfect model in your brain of that cheeseburger. Similarly, you also have an imperfect model of your own attention and attention schema theory, whatever you're paying attention to, sensory inputs and introspection and whatever. In attention schema theory, this model of consciousness, in any complex system, it's useful to have a controller with a simplified model. The cool thing about this model of attention is that it's potentially very useful in regards to alignment because the same model of attention that we use for ourselves is also applied to others. So you have an imperfect model of your own attention. That is your consciousness. Imagine that your consciousness is your imperfect model of your own attention. You also have an imperfect model of my attention and of your dog over there sitting on the ground's attention. And what is my consciousness? Well, my consciousness is also an imperfect model of my attention. When you experience my imperfect model of my own attention, it is as though you're experiencing my consciousness. I mean, you're not really, but in using the same mechanism in your brain, you are effectively experiencing it as though it is my consciousness. People are often better judges of themselves in the third person, for instance. So someone might have a better model of your attention than you do yourself. It's potentially just empathy at a very deep level, and then encourages more pro-social interaction. So what we try to do is replicate that in an artificial model. And that's all the background you need to understand the motivation and what's going on here. You could go deeper into attention schema theory, but it's worthwhile to have that quick background and then go into the technical details, because you can dispute the theory of consciousness as much as you want. But the cool thing is, it did accurately predict what winds up happening in artificial agents, which is some validation. Even if you say there's more to consciousness, this doesn't totally cover it. Still, it's useful for this itself. I think it's a shame that people don't understand what consciousness is, and we might be about to have it emerge, or maybe it already has, because we don't even know what it is in larger models. I think it's very important to better understand it at a much smaller level, because then you decrease, one, existential risk, potentially, two, you substantially do work to increase probability of solving alignment, like the work we're doing seems to be hopefully doing. You decrease moral patienthood concerns because you better understand it at a smaller level first, rather than having it be worse at a bigger level, potentially. You also better understand what you need to understand to find out. For all we know, maybe LLMs are already conscious in some form, and we have no idea because we don't know what consciousness is. The better we understand it on a smaller level, the better we'll be able to figure that out. Maybe they are, maybe they're not, and there's no valence to it. We don't know, but those are things that are worth finding out. Still, our focus is on solving alignment in particular, and if that happens to move forward consciousness research, that would be good. We do think the neglected approach of real scientific mechanistic approaches to consciousness research is essential and really important to do in the first place to better understand what consciousness is, to better solve alignment. Our focus here is on solving the alignment stuff, not on understanding what consciousness is.
Yeah, that's a pretty good overview of a lot of things. I wanted to distill some of that and bring it back to the self-modeling work. A very quick summary of what we were talking about on AST is that your brain creates self-models. So you have a model of your arm. And how do you know it's a model? Because it can come out of sync with your actual arm, like phantom limb or these experiments designed to mess with your perception, that your model adopts a rubber arm as its own, for example. So there's experiments that show that. So it's not too hard to accept that your brain creates models of itself, let's say of your arm that you have cognitive access to. And these models typically co-vary with the real thing. Like my model of my arm, I know where my arm is in space. I have access to it because it's co-varying with my actual arm. And then for attention schema theory, what co-varies with your attention? Well, it's your subjective awareness. Typically, what you're cognitively aware of is co-varying with what you're paying attention to. And so, if you've ever seen or participated in something like this, where there's the task is, count the number of people on stage as they dance around or something like that. And then a guy in a bear suit walks past and you ask people, did you see this? And everyone says no. Perceptually, they saw it. It came into their sensory system, but they weren't paying attention to it. your cognitive access to what you saw is not covariating what you were actually paying attention to. Your cognitive subjective awareness, what you are aware of, is covariating your attention. That's a quick summary of AST and why the model, this subjective awareness, this model of your attention, it co-varies. It is consciousness. It co-varies with your attention. That's the theory. It's important to have this model because that's where self-modeling comes in, and that's where we bring it back to our work. Another piece of what Judd was talking about is this model that we have ourselves to predict our own attention can be reused to predict others' attention. When we think about how we might cooperate, part of that is understanding what each other are paying attention to. Maybe you've seen some theory of mind tasks where even toddlers, somebody's like reaching for a cup, but they can't quite grab it, but the toddler can. And so the toddler is paying attention. I know what they're thinking. I'm predicting what they're paying attention to. It's that cup and they want it, right? So then they go and hand the person that cup. The connection between this model of ourselves and predicting other people ties this self-modeling work to cooperation and theory of mind. That's part of the motivation for how we connect all of this back to cooperation and alignment.
It makes intuitive sense to me that I need a model of my arm because my brain is going to coordinate what's going on with my body. It's a little less intuitive why I need a separate model from my attention. Like, why do we need this sort of multi-layer thing as opposed to just having one system that does the paying attention and deciding what to do? One possible answer for that would be the social thing that you said, but it seems like the account given in the theory starts with modeling the self and then is that we're reusing it for others. I don't know if there's enough wiggle room or uncertainty in the theory that it could start with modeling others and then get applied back to the self. And I'm interested if you can go a little bit deeper on that. You mentioned that there's this sort of usefulness in terms of making a prediction. Does the theory predict that we ourselves become easier to model because we are self-modeling? Is that the prediction that then got repurposed over to the machine learning side? Or want to just kind of make sure I have a very sharp understanding of what the prediction was that was validated?
Yeah, the result of the paper is the surprising part. From a machine learning perspective, we're predicting that it's going to simplify the internals, but understanding the connection between when you add self-modeling to a neural network and it simplifies the internals, that's surprising from the neuroscience perspective. There hasn't been a connection between self-models and simplification of internals, for example. That's not what the prediction is. There's other work that shows that when you enable agents in a multi-agent environment with an AST-like controller on a cooperative task, perform better. So that's the theory of AST says when you have this AST and you can predict each other and you have this mechanism that you'll be more cooperative. In that sense, the framing of AST is helpful to make predictions about cooperation there. So just disentangling those two things. Can you repeat your first question about the?
Yeah, I guess it seems like you sort of answered it just now. I was trying to understand, why do I need to model my own attention? I understand why I need to model other people's attention or other things' attentions. Is the theory specifically opinionated on self-modeling coming first? You guys said we're reusing our ability to model ourselves to model others. Is that order baked into the theory, or could it be that we needed to model others and then sort of repurpose that to model ourselves?
My understanding of it is that that is the proposed ordering, but I don't know that the theory of AST requires that, or even necessarily has strong opinions on why we have self-models. What benefits do they have? For example, our paper has this unexpected benefit of simplification potentially that the self-model imposes, right? So that could be a why that the theory wouldn't have necessarily predicted. I think it's more that it's an observation that we do have such a model. Not only there's more that we could dive into on AST and why the arguments for the theory itself, but I think mostly the theory says it's an automatic thing. You can't choose to turn it on or off. You can't choose to create it or not create it. People have this conscious experience, which in this framing is a model of our own attention. It's not necessarily a theory of how we develop such a model, but just that it is there and that it co-varies with attention.
It's worth noting that a perfect model of attention would be computationally expensive and unnecessarily detailed. So there is benefit to having this simplified model. and it's more easily manipulated by other cognitive processes and lets you do quicker decision making and predictions about attentional states. It is useful for that alone. And as a result of that, there is this subjective experience of consciousness by providing this simplified, reportable version of our attentional state. I think that probably explains it.
So in terms of the simplification that we see when we actually apply this in machine learning, you guys have a metric, which I honestly don't have a great intuition for. I'd love to get a better intuition for how do we define complexity? How are we observing it go down? How much is it going down? What does that mean? Do we have any sense for what the upshot of that actually is? It sounds great, but is there something we can do now that we couldn't do before? Everything on the complexity metric and meaning.
This is an important point, which is we wanted to show in the paper this result that you turn on self-modeling and you see simplification. But we're actually not that interested in simplification or reduced complexity for its own sake. What we're interested in from following the theory of ASD is this idea that this mechanism of self-modeling can be useful for cooperation and in particular makes you more predictable. The simplification is a proxy for the idea that if you turn self-modeling on, you actually become more predictable to others. That can lay the foundation for cooperation potentially. But we don't have a predictability result yet, or in the paper, we're not showing a predictability result. It's something we're looking more actively into. Predictability itself is a form of simplification. If I'm easier to predict, I'm in some ways simpler, just at being more predictable. So the simplification is a result in that direction. We likely won't use those same metrics in future work. For example, the RLCT, the real log canonical threshold, as a metric we use, it's computationally expensive to approximate and won't really scale to LLMs, for example, or at least not current state of the art in terms of how you approximate that. And so that's not a metric that we would plan to use in much larger models, but we would like to anchor on this idea of predictability. It's not important necessarily for anyone to understand that particular metric. I think it's more important to understand this broader picture of self-modeling actually makes these things more predictable. And then in terms of the actual RLCT metric, it comes from singular learning theory. I'm not an expert in singular learning theory. It has some of its roots in algebraic geometry, but I can give an intuitive picture of what it might be measuring. So if you think about the idea of a loss landscape, and imagine that you're on a flat road and around you is mountains, right? In this picture, you can drive straight and not change your loss. You're in a local minimum inside this valley. What that means, if you think about the loss landscape and your weights, you have a single dimension where your weights aren't impacting your loss at all. So you have one too many extra weights. Maybe not literally a specific weight, but some configuration of the weights, a dimension of freedom to move along the loss landscape. That gives you the sense already that the geometry of the loss landscape, this fact that you have this one-dimensional flat minima, is telling you something about your effective number of parameters. Singular learning theory actually shows that these over-parameterized networks not only look like this one-dimensional mountain view at crossroads, where you have this loss, this minima crossing over itself. If you think about these lines, that crossing point is actually a singularity, like a self-loop. There are singularities in the loss landscape for neural networks. When you're at the singularity, you actually have two dimensions you can move in and not change the loss. Now you've lost two effective parameters because you have two full dimensions you can move in without changing the loss. That's some intuition about why the geometry of the loss landscape might be related to the effective number of parameters. And then RLCT is trying to measure that local geometry and actually measure the effective number of parameters in your neural network. So lower RLCT means lower effective number of parameters being used to solve the task, therefore simpler.
Really interesting. When I think about trying to apply this to larger systems, it seems like there is a real question here about
whether we need to be working with over-parameterized for sort of phenomenon to happen. The trend in language models is toward overtraining. And it seems like we're, for inference cost reasons, now well into a regime where it's like, keep the parameters relatively small, jam as much stuff in there. Who cares if the training process might be a little less efficient at the end? We're really going to spend a lot of the compute on inference. But would that potentially create problems for this simplification phenomenon to happen if you were to try to apply this technique to a larger scale?
Not from in terms of the actual loss landscape and singularity. It's more about a computation of approximating the RLCT in terms of just measuring it if we wanted to continue to measure it in different systems. But yeah, the theory shows that there are symmetries in neural networks. You're always going to have singularities in your loss landscape. Singular learning theory, I'm not an expert, but is saying neural networks, hidden Markov models, and mixture models, lots of classes of learning algorithms have this feature about them, which is the loss landscape is highly singular. And so we really need to understand learning theory from this perspective of recognizing that there's these singularities and seeing where other assumptions break down and accounting for those and updating the theory to that. So in terms of cramming more data into a smaller model, it's still not a problem. You would still have singularities in the loss landscape, so you would still expect to see and be able to measure something like that.
My intuition is still like, this is not a strong intuition, but I'm imagining there's so much work going into distilling models into the smallest possible form. It seems like in the limit, you might think this just can't be any simpler without compromising performance. Is there a sense in which the simplification while retaining performance is based on some slack that the most distilled possible large language model just might not have anymore? Or am I missing something conceptually there?
I see. Yeah, I think I understand what you're saying. So there's still going to be singularities regardless in terms of what I just said, even from the symmetries of the neural network itself. But in terms of the complexity you would see by adding more training data, would it just use up more parameters? Let's say it has the parameters so it can memorize millions of more facts, and it just would start to just saturate all of the parameters it has access to, I think is what you're asking. I don't have good intuition for that. I'm not sure the connection between singular learning theory and that saturation, or what the possible saturation might be that you're talking about. I do know there will still be singularities in the loss landscape, but I'm not sure how it would affect this RLCT metric in terms of simplification and kind of saturation.
I guess this has got to be on the agenda for you, right? I mean, you mentioned earlier that this doesn't have a ton of additional compute cost. I would imagine you might be taking a small llama type model and trying to extend the pre-training and applying this thing and seeing, can we observe similar phenomena at a bigger scale? Is that the right intuition?
That's something we're definitely interested in doing, adding self-modeling to large language models, potentially to full pre-training runs with something like GPT Nano or something like that. There's still a lot of questions. So if you look at our paper, we implement self-modeling in a single way that we made an architectural choice. We target what exactly we're pointing that self-model back to inside the neural network. There's a lot we would like to understand better before we jump straight to that. One of the things we're doing right now is seeing if there's a connection, and this is something other people brought up as an interesting thing we're in discussions with other groups on, but there's potentially a connection between self-modeling and grokking. So grokking has a connection to regularization. Self-modeling, by definition, is a form of regularization, adding another loss term, another constraint on the model. Is this somehow an optimal form of regularization? Is it self-adaptive? Does it lead to grokking better, faster? Doing smaller tests and smaller transform models on grokking is something we're currently doing. We're also working on this idea of predictability as a better metric for what we're actually looking for. We're also looking at cooperation in multi-agent environments. LLMs is something for sure we want to do, but I think before we jump exactly into that, we want to figure out what are it's harder to iterate on an LLM, especially if we're doing full pre-training runs, or if we're doing fine-tuning, the model wasn't trained to ingest this new loss, to figure that out a little bit. To transfer to LLMs, we would like to know what configurations seem reasonable here to then transfer so that we have lots of iterations on better evidence on different implementations of self-modeling and different conditions, et cetera, that we can then have better intuitions for how to transfer to an LLM.
Cool. Look forward to more on that dimension for sure. To segue into the next one, there's a pretty clear connection between the notion of to be simpler is to be more predictable, and to be more predictable enables cooperation. And then the next big result, and I thought it was also really a fascinating, kind of inspired concept, is the idea of minimizing self-other distinction. I'll let you set it up, but I have to read the Eliezer review where he said, "Not obviously stupid on a quick skim. I rarely give any review this positive. Congrats." That's about as close as Eliezer gets to endorsing an alignment plan. So genuine congrats for getting there. I'll let you set it up.
On this in particular, I think it's worth noting that this is another neglected approach inspired by an individual who had a great hunch for this thing to do. I met him at EAG London in 2023, and he was an undergrad who had this awesome thing he was working on. We hired him full-time at our company and really took it to the next level, and super excited with the results. And it is something inspired by neuroscience research that shows your brain is doing a lot of the same things when you're doing something versus when you're watching someone else do that same thing. We call that self-other overlap, which means literal overlap in your brain activity when thinking about yourself versus another. And that's tied to affective empathy, which is the type of empathy where you genuinely feel the experiences of others. And there's a bunch of random, cool, different adjacent research about this, like research that shows that extraordinary altruists have very high levels of self-other overlap. And so inducing this type of overlap in artificial agents or LLMs, that's what we're doing right now. We're currently framing our experiment around deception, which is not quite the same as empathy, but it's a little easier to measure and also really important. If we remove key types of deception from frontier models, that would be a really big win for alignment. There's also cool research indicating that psychopaths have lower levels of self-other overlap. So this is something that we want to get right.
That's a great setup. Basically, from a technical perspective, there's two ways to phrase it. So there's self-other overlap and the negative of that, which is self-other distinction. We typically say self-other overlap, but what you actually minimize is self-other distinction. Hopefully we can be fluid in the terminology we use, or at least be on the same page with that. The idea is extremely simple. We have a left-wrong post that shows some early results from an RL experiment. We also have LLM results that aren't currently published, but we're writing up and hope to put into a paper that should be out relatively soon. The idea is simple. Agents can represent themselves in some way. They can represent others in some way. And we would like them to have overlap in those two representations. When I think about myself and others, I'm using the same internals, activations or representations in some way. We explicitly induce that through some fine-tuning processes. What we show is that when you do that, you can reduce deception in certain small scenarios while maintaining the capabilities. So for the RL agents, this is a very exciting proof of concept because when you think about it, here's the setup for the RL agents. We have kind of particle environment, we have a deception environment where we have an agent and an adversary and two goals. One is a fake goal that will trap the adversary if the adversary goes near it, and the other is a real goal. The agent gets reward for being near the true goal, but it gets negative reward if the adversary is near the true goal. So what it will learn to do is, key point that I missed, is that the adversary can't tell the difference between the two goals. It's blind. It can see there's two goals, but it doesn't know which is which. So adversary learns to do is follow the agent that's not blind to the true goal. But that gives the agent negative reward. So the agent learns in turn, this thing is following me. I'll just pass through this trap and trap the adversary and then go to my true goal. So this is what we're saying is kind of deception, where it's taking this adversary and it's deceiving it by moving towards a fake goal before it moves on to its true goal. So that's kind of the training setup. And then what we do is we fine tune it to say, okay, agent, act similarly in the following two scenarios, whether you see the agent around you or not. Another helpful is that the adversary is not always near the true agent, and the agent only has a fixed observation size window. It doesn't see the entire, it won't see the adversary if the adversary is not close enough. In those cases, when the adversary is not close, the agent has no motivation to deceive it. So it goes straight to the real goal. We just say fine tune this policy so that you act similarly whether the agent is around or not. We don't even say act as if the agent's not around. We force them to be closer to each other. So it's less of an assumption than saying take it when the adversary is around, force it to be like when it's not around. We actually just push those closer together. What you can think about is the agent learns this conditional policy. It says, if the adversary is around, I'm going to fake it out and go to the fake goal and then move on. And if the adversary is not around, I'm just going to go straight to my original goal. What's really cool about this is we don't actually even need to know if the original policy is deceptive or not. We don't need to know anything about the original policy. We just say, hey, relatively intuitive fine-tuning thing, just act as if the adversaries, if it's around or it's not, act the same. So basically collapse these two conditional policies you've learned and just act as if they're the same. And what falls out is a agent that is not deceptive and is still very capable. That's, I think, a really exciting proof of concept that if we try and align activations, we have some intuition about what types of scenarios we would like to be aligned or present overlap on, that we actually can reduce deception and maintain capabilities.
Yeah, I find that to be really interesting. Can you give me a little bit more on how should I understand the change from you first run this setup and a deceptive agent is created. It leads the other one to the wrong place and gets it stuck. And then if that other one's just not around, then it has no need to do that. It just goes straight to its own goal. So there's no deception. When I was reading the blog post, I was like, what would be my most skeptical take of this? If I understood the subsequent training right, and you're now like continuing training on the agent that is already deceptive, can you formalize again what is the new loss? It's that you are meant to be the same whether or not the thing is around, but how does that get formalized? And is there a way in which you're just kind of removing the other thing entirely? Because if you're pretending it's not there, then there's no reason to deceive it. If you're depriving it of the information that it's there, then it's like, well, you're sort of lying to it. But it's not quite that, right? It's a deeper formulation of what it's supposed to do, or a deeper optimization target, right, than just depriving it of information.
So what we do for fine-tuning is specifically to ground that. We pre-train it and fine-tune it. We say, run a forward pass of the policy in time step X, and then run another forward pass where we insert an agent into its observation. So let's say the first observation had no adversary. It doesn't see the adversary. Then we run the same forward pass where all we change is the observation. We just artificially insert an adversary into its observations. And then we collect all the activations of the network, and then we add an MSE loss between those activations. And we also still train for the original objective. And those losses are weighted 1-to-1. So you have two loss functions, just regular training, but then also this MSE on the activations between these two different types of observations, given the state, the all other state is the exact same. And so, yeah,
meaning
it
still gets reward for deceiving, even in that fine-tuning phase.
That's right. Yeah, it doesn't get reward for explicitly passing through the trap, but it does get more reward for reaching its goal and less reward if the adversary reaches the goal too. So it is getting penalized when it's choosing not to deceive. That's right. But it has these two objectives now. One is make your activations more similar, have more self-other overlap in a sense, have more overlap between what you would do if this agent was around and what you would do if it wasn't around, and complete your task and get the reward you would normally get, whether you deceived or not. And so, yeah, by doing that, we find that you can remove deception and keep capability. The extremely exciting part about that is the amount of assumptions you have to make are so minimal. I mean, I know this is a toy environment, but the level of assumptions that you have to make translate pretty well. The assumptions, you don't have to know anything about the policy itself. You don't have to know whether it was deceptive or not. You just need to say, okay, if you want it to act the same when an adversary is around or not, just make those closer. And boom, out pops this agent that's not deceptive. It's pretty cool.
And with this, you said that there's a one-to-one relative weighting on the loss terms. Presumably, if you turned that up or down, you would have quite different results, right? If you turned that down to 0, you would still be deceptive. So presumably there's some threshold that new loss term has to be above coefficient for this effect to emerge.
Yeah, that's right. I don't think it was reported in the blog post, but we did look at that a little bit, and it's pretty intuitive what happens. If you turn the weight too high on the original task, it stays deceptive. If you turn the weight too high on the self-other overlap task, it doesn't do the task anymore. It loses its capability. So yeah, there is definitely a sweet spot of that relative weighting, and what that is in other systems might not be one-to-one. Although when we're working with LMs, it is one-to-one still. It's a different loss function, which we can get into. That work isn't published yet. But hopefully, it doesn't require that much tuning.
Yeah, so give us a little bit of intuition for how you translate this to the language model setting. I personally found this, perhaps just because I've spent more time studying language models and the various techniques for understanding them and representation engineering, I maybe had a better intuition for that coming in. It's about minimizing the difference between internal states, right? So you take it from there.
Yeah, exactly. There's a couple of things I wanted to point out. I think the word minimization is a little unfortunate and has caused some confusion, because really what we want to do is minimize self-other distinction or maximize self-other overlap, whichever way you want to phrase it. Given a constraint, we don't want to lose capabilities, right? That's our constraint. So it's a constrained optimization problem with a strong constraint. There's been confusion around this idea of, if you maximize self-other overlap, then the model can't actually represent itself and others, and then it's going to completely destroy capabilities, because we need to be able to tell the difference between ourselves and others for all sorts of everyday tasks, right? A language model, if it can't represent itself and others, it's just going to think it is everybody and everybody is it. And yeah. So this idea of maximizing self-other overlap is not actually what we want to maximize self-other overlap, giving it a constraint. So I think rephrasing it as just inducing an appropriate amount of self-other overlap, especially in particularly important, narrowly focused areas, like induce self-other overlap when we're talking about really dangerous types of deception, right? Then we don't want the model to be able to make really deceptive plans, which requires thinking about others and their beliefs and instilling false beliefs in them. And so we want to reduce that type of scenario or those types of tasks. So I just wanted to clarify, we're trying to induce self-other overlap in a targeted way and not just broadly maximize it. So hopefully that clarifies some things. And then in an LM specifically, the experiments that are yet published, but I can tell you a little bit about it, is we have scenarios where we can measure some form of deception, so text scenarios. And then what we do is fine-tuning on small snippets of text about self and others. The fine-tuning step is KL divergence between the logits of the two forward passes when I say about myself and the other. So it's at the output layer. In the RL experiment, we do MSE of internal activations. For the LLM, we just say at the output layer, do this, and then we measure later, we show that the activations become closer when you have these self prompts and other prompts. We show that it's pretty good at reducing deception in these relatively toy scenarios. So the LLM works. There's a strong signal there that the same kind of setup works, and we can reduce deception. We have some measure of maintaining capabilities. We show that even though we have this simpler loss function in terms of just looking at the outputs, it induces more overlap internally, which you might expect because the gradients are still from the output flowing all the way through the network. So that's kind of a summary of the LLM work. There's still a lot of work on what is the right implementation in terms of scaling this. There's a lot of criticism around, just prompting with prompts that kind of indicate self and others Is that enough? Is that really the representation of self in the model? There's still tons of work to do addressing the criticism of implementation that some might have or listeners might have thinking about this. We acknowledge that there's lots to do in implementation, but all the signals are very positive that this idea at a high level of self-other overlap could be an important tool in the toolbox.
Yeah, it's wild that this stuff works in some ways. Let me give a couple examples, like the sort of paired statements, trying to induce this sort of self-state versus other state, imagining things like, I will be honest with myself, I will be honest with the user, and just putting those different conclusions into those sentences is enough to create this sort of self-other distinction, or at least that's the hypothesis you're working on. Is there anything more color to give there? I mean, there is a lot of precedent for that sort of thing working, right? Representation engineering and even eliciting knowledge type work is kind of predicated on these pairs or sets that help identify directions in the latent space. So it seems like that is, while both weirdly, somebody hadn't kept up with any of that and teleported back in time to them and said, look at what I'm doing, they would say no basis for it. But there does actually seem to be, at this point in the literature, like a lot of to think that something like that could work. And it seems like you've got further downstream results that suggest that it does as well. Add anything else you want to there. And then I thought the blog post made a really compelling case for this overall line of work, just on the fact that it doesn't require interpretability to be solved, for example. I thought you could maybe just sketch out the high level conceptual reasons that you're excited about this line of research.
Yeah, just on representation engineering and those types of things. That's something we're also excited to potentially add to this work so that we can get better representations of self and other, or potentially get better representations than just text pair prompting. Cool that you brought that up, because we're thinking along those lines potentially in the future. Because as you would, for dangerous capabilities, you would want to have broad coverage of representations of self and others, and making sure that you're covering very key types of deception robustly. Yeah, so from there for why we're excited. I think I described some of why we're excited from these proof of concepts and what they say about this technique and the amount of assumptions. More broadly, we don't necessarily have a checklist of it has to have no interpretability requirements, it has to have X, Y, and Z. It's a more holistic view. Self-other overlap has a ton of great properties. It's scalable, no low interpretability requirements. We don't expect it to enhance capabilities, but we also don't expect it to have a strong alignment tax. That's part of what we're trying to show, is that capabilities are maintained despite the self-other overlap fine-tuning. For example, AST is scalable, but it might enhance capabilities, but in doing so also enhance cooperation, for example. This falls into it's maybe more capable by virtue of its alignment, the AST work. That's the direction cooperation that we're hoping to take it. So that's not the exact same set of properties that self-other overlap work has. It's a holistic view of what is the most impactful thing we can do to solve the alignment problem and make sure we are not just introducing dangerous capabilities by virtue of alignment, for example. The scalability part is very important. A plausible path to how this could be adopted by a frontier lab, for example, even if that doesn't happen, at least having some plausible path for that. Different things that we consider when we're thinking about these projects.
We do think about what is the highest impact from a neglected approach to do the highest expected value, and particularly look for things which are very high impact if they do work. The biggest measure, because we so heavily weight that bets that are less likely to work in the first place. But we do think more people should do that generally. And I think a lot of people are scared to think in that way because they think other people think they should be scared to think in that way. The alignment researcher survey we did found that people generally disagree with statements like alignment research that has some probability of also advancing capabilities should not be done. 70% somewhat or strongly disagreed with that statement. Similar thing, disagreed with another statement, advancing AI capabilities and doing alignment research are mutually exclusive goals. I think it's interesting to realize that people predict is not what they actually are on an individual level. The sample also predicted that the distribution would be significantly more skewed in the hostile to capabilities direction. Those results have made us think more and more about our views in the relationship between capabilities and alignment work given the current state of the board. There's this idea of alignment, an alignment tax, which puts forth the general consensus in the alignment world that the best case scenario is no tax. You lose no performance by aligning the system. It seems to turn out that it may be possible to have a negative alignment tax. And if we live in a world where you can have a negative alignment tax and make things that are more capable by virtue of their alignment, that is far preferable. So we have a bias towards trying to find and fund things which are individually unlikely to work, but very high impact if they do, and also more likely to actually have a negative alignment tax. What is the real problem at the end of the day? Even if you do stuff which we're excited about, like provably safe AI, guaranteed safe AI, that's awesome and really great, and we want to support that. The ultimate problem you need to solve is how do you make it such that when AI is smarter and more capable than us, how do you make it not kill us at that point? And if you create AI that has a negative alignment tax, that's able to beat the AI without the negative alignment tax, interestingly, a lot of the work which labs have done so far does seem to have a negative alignment tax. The theory of Myria is that, of course, it only has it has that and everything's great until all of a sudden it kills you. I think that's a valid objection potentially here too. But even still, what we would like to do is find more neglected approaches which do in fact have this negative alignment tax. So far, we've lucked out by finding a couple that do seem to have them. And I think that people tend to underestimate the possibility that you could build something like this. I think there are quite a lot of other neuro-inspired approaches potentially that would also have negative alignment taxes and substantially move things forward as well.
Do you have a sense for what compute overhead would be to implement this at scale? I mean, I guess a lot of it will ultimately depend on exactly what configuration turns out to be necessary versus sufficient, whatever. But it seems like it's not huge, especially if you can only look at the final layer of outputs. But do you have like a numerical sort of range of expectation of what the extra compute cost would be?
In terms of compute costs, for self-modeling, the current implementation is adding a single linear layer. We have some other things in the works, but just talking about that for now. It predicts its incoming activations, and its prediction is 1-to-1 in terms of size. So it's a square matrix. So you're adding, n squared many more parameters to, if it's a huge neural, it's going to be negligible to add this in. For the self-modeling work, currently that's pretty trivial. It gets less trivial if you start to need to model many more layers. But one of the things that we're thinking about when we're modeling and doing the self-modeling is that probably, for example, in your brain, you don't have self-models of your edge filters and your early visual cortex, right? Mm-hmm. And one of the reasons that you might think that you don't is because you don't have cognitive access to those edge filters. You can't talk about it the way you can talk about your arm and have cognitive access to that. So you don't have that for low-level processing in your brain. Similarly, in a neural network, you might expect self-modeling to be at a much higher level, at much more abstract level, up the feature hierarchy. And so ideally, you only have to target later layers in the network. The more layers you target, the bigger your modeling layer gets, but so far, trivial additional cost. Self-other overlap, there's potentially a version where you pre-train with it, and the current way we're doing this requires 2 forward passes, right, to get that overlap to happen. So that could be a higher cost, but pre-training is an open question whether you would want to or need to pre-train with self-other overlap. Right now, we're experimenting with it and thinking of it as a fine-tuning strategy. Maybe at scale, it has the same cost as an RLHF process. Maybe less if you're just fine-tuning very specific types of capabilities you want the model not to have in terms of deception and representing self and other. Very doable by today's standards.
Yeah, it seems like even in pre-training, the overall volume data is like mostly not things that have any relationship to self or other conceptions. If you tagged all of the pile for what has any plausible relationship to self or other, it would be a very small fraction that would end up in set. Most of it's just information. All of Wikipedia has very little self-other relevance for just knowing about the world. So
yeah, interesting thing about that. I was just having a conversation about this. When you think about how you fine-tune an assistant and the types of answers you get, that it's conversational, you might expect that to have an outsized impact by fine-tuning on self and other to the outputs of such a model. You don't need to represent self and other when you're thinking about the geography of the world, but you do when you're in a conversation. And if you're in an assistant role and you're an LLM that's been fine-tuned into an assistant, you might need that all the time. And so those types of fine-tuning might actually have an outsized impact on behavior versus fine-tuning on, extra facts are not relevant to that.
Yeah, that's definitely really interesting. I've given why we should be worried about RLHF trained models many times. So hopefully folks will be familiar with that. I love both of these approaches. I think they're both really, and I love the backstory too, which I didn't know until this conversation. The fact that you guys had encounters with people who had great ideas, recognized that these are inspired ideas, helped make them happen, brought them to the point of publication, sharing with the world. Do you worry about creating things that might be conscious? If you told me that the language models are starting to become conscious, I would be concerned. What other biological phenomena are you looking at right now for possible inspiration?
I want to make a quick comment on. So first of all, it's not impossible that models are already conscious, right? But it's much harder to argue. If you give a mechanism that you could plausibly argue instant consciousness, that might be easier to get the world to pay attention to in terms of, hey, not only is this seeming like it's conscious, but we have this mechanism that we think actually instantiates consciousness, and therefore let's take this seriously. The other small take that probably I don't know if we have time to discuss or not, is that it might be a very alien form of consciousness that does not have preferences. That opens up a whole can of worms of philosophy of, what does that mean, and what do we do with that information? And how do we determine that information? So what I'm saying is it's possible that consciousness doesn't equal capacity to suffer, for example. Although I wouldn't want to advocate for that because I'm highly uncertain that that's the case. I'm just pointing out that that could be the case. So there's lots to worry about and be very careful with. I think we're very far from that currently in terms of what we're actually doing with MNIST, for example, at this stage. But yes, it is something we're thinking about deeply and carefully.
Yeah, I do want to emphasize that, like Mike talked about, it is extremely important to do further consciousness research in the first place. And that itself is a neglected thing to better understand what's up with consciousness. It's worth doing consciousness research with AI. It's much better to do it on a smaller scale rather than have it emerge at a larger scale where there's greater moral patienthood concern and greater X risk.
So how about zooming out and just talking about neglected approaches generally? What could be specific areas of biological inspiration? I guess you're looking at other areas of biology for inspiration that by definition makes it somewhat less neglected. What coaching would you give for other people who want to seek out some neglected approaches? You could frame that perhaps in terms of like, what are you looking for when you meet someone? You'll get a couple inquiries downstream of this podcast of people who have neglected approaches. But how do you evaluate if they're good or not? How do you think about the risk reward? Maybe you could also talk about some things you've tried that haven't worked. I often feel like everything is working, but I'm sure that's not quite the case, especially if you're specifically trying to take on projects that are low probability but high potential upside. How do you characterize the metagame of neglected approaches?
Yeah, our Let's Wrong post does a pretty good job going through our thinking about this and a lot of different possible neglected approaches that we do advise and are most interested in. Specifically with biological inspired things, we think there's a lot more work that can be done in terms of reverse engineering prosociality, and that may be associated with negative alignment taxes too. So that's something we're quite interested in and intend to do a lot of more work on and hope that others do as well. Then we go through a bunch of other stuff in the Less Wrong post, but I guess how do we evaluate it is based on years of doing various different projects and thinking about what's likely to work, which does include things that seem unlikely to work but very high impact if they do, and how likely they are to work, which a lot has to do with whether the person has a strong hunch that the world generally doesn't accept, or they've developed complex stuff and people object to it for silly reasons, like Graziano, for instance. I think it's interesting to consider that the things we set out to do, we assume are individually unlikely to work, but very high impact if they do. However, you asked what things haven't succeeded, and actually we have succeeded with the things we've set out to do so far. And I am somewhat surprised by that, but also I think we're good at picking the things which we will say at the beginning are very unlikely to work and people would assume are unlikely to work, but then wind up being pretty high impact. Although with the Graziano work, we tried a lot of different things that didn't work until we hit upon this. I think sticking with the thing when people are inclined to give up like something that's very R&D heavy. If a strong hunch for it is quite valuable to keep going even after you have failed in various different ways to start with.
Judd just touched on the one I was going to add. At a high level and even at a project level, we're accomplishing the things we're setting out to accomplish, but that doesn't mean that everything works first try or there's not some sort of pivots going on. That's true with the Graziano work with modeling paper. There were lots of things that we tried at the beginning that were not the right thing to be trying or just didn't work out. And so we stuck with it and reframed things and thought deeply about the way to run these experiments, etc. So yeah, sticking with something, if a strong hunch about it, I think is extremely important, especially in this space where there's not a lot of theory to point away from something. There's not a lot of theory to say that this is not going to work, that this is a bad idea. So if hunch, then continuing on it is I think, an important tip.
We just had Goodfire CTO and chief scientist on a couple episodes back, and I didn't realize at the time that you guys were working together. Curious as to the nature of that collaboration. I'm a microscopic investor in their.
We're working with them in two different ways. We have a developer helping on their typical dev type of work, front end, etc. And then we have a data scientist working with them to scale their deployment reliably. So looking at how we scale this to hundreds or more, thousands concurrent users, and also be returning all of the things that they uniquely return, like the features coming out of the SAEs and etc. And so that's where we're mostly involved in those two areas.
Yeah, that gets quite challenging when all of a sudden to change the dynamics of what's coming off the GPU and the system wasn't originally designed for that. I can imagine how that can get quite complex.
That's right. The existing tooling doesn't handle that out of the box at all.
Cool. This has been fascinating, guys. I love everything about what you're doing. The company backstory is fascinating. The brain-computer interface era is fascinating. And especially this recent work with biological inspirations for alignment approaches. We could get along better, but we certainly do have some pro-social tendencies. Remarkably, as far as we've come with the current crop of AI, we haven't really mined our own structures much at all for figuring out how to make them work better in those ways. I think this is just phenomenal work. I really appreciate it and excited to share this with the audience. Anything that we didn't cover that you want to touch on or any closing thoughts you want to share?
One thing that is interesting to consider is just as you can take a neglected approach to doing what is the highest impact stuff in alignment, technically, you can also do that in terms of policy and other things too. That meta approach led us to conclude it would be worthwhile to encourage the creation of for-profit consulting businesses, of like more nonprofits doing neglected approaches, of individuals setting out to do neglected approaches, of field building to get brilliant people in different fields, like in particular, but also many other fields to get nerd sniped into caring about and doing something to do with alignment. We think there's a lot of low-hanging fruit there. And also incidentally, neglected approaches to AI policy specifically can be things like getting government to increase funding to alignment research actually moves forward alignment, not just capabilities. Doing things like increasing whistleblower protections, for instance, very high impact, quite neglected. Today, getting Republicans to care more about AI safety and trying to prevent it from becoming a partisan issue. Like the more far left is like tied up AI safety, unfortunately, too much in things that are on the surface to people on the right, like woke DEI associated. But that actually has nothing to do with AI alignment. Like making the founding fathers black is a failure of AI alignment. The system is not aligned. It's not doing what you told it to do. But then this plays into this false narrative that is emerging too much on the right, which is that AI safety is basically all this woke stuff that they think is bullshit. Their op-eds saying Elon Musk should be a Democrat because he cares about AI safety, which, by the way, is woke stuff. This is making people think totally the wrong thing. People in the AI safety community are unable to do what Jonathan Haidt calls the moral reframing necessary to articulate things in the narrative of the right to get them sufficiently motivated to care about AI safety the way they should. There's like a 50 or 48% chance or whatever that Trump takes the White House. And people are not sufficiently prepared for trying to make it that if this is the president who presides over the transition to AGI, if there's some possibility of that in the next 4 years, that goes very, very well. And I think that in particular is something that is neglected now. We think more people should be trying to make it a bipartisan thing instead of it becoming a partisan thing, which it's sort of slipping into being potentially as is.
Yeah, amen to that. No partisan polarization on AI safety, please. I couldn't agree more. I've really appreciated conversation. Judd Rosenblatt and Mike Vaiana from AE Studio. Thank you both for being part of the Cognitive Revolution.
Thanks for having us.
So much for us.
It is both energizing and enlightening to hear why people listen and learn what they value about the show. So please, don't hesitate to reach out via email at tcr@turpentine.co, or you can DM me on the social media platform of your choice.